Solid-state energy industry. Phase I fundraising briefing. Los Angeles, California automated production project. Solid-state power industry is an energy technology company focused on magnetic power generation and solid-state energy storage, with a clear execution strategy centered on engineering, standardization, and scalable manufacturing. Rather than operating as a pure technology developer, the company's core objective is to establish automated manufacturing facilities, securing control over key components, system integration, and production capacity as long-term energy assets. The company's energy modules are designed for electric vehicles and mobility platforms, providing continuous and stable onboard power support during operation, significantly reducing dependence on external charging infrastructure. This manufacturing-led approach redefines the EV energy supply model and delivers strong engineering advantages under extreme conditions, including high-temperature operational stability, reliable cold start performance, and long-duration energy safety. Through factory development and capacity expansion, solid-state power industry converts proprietary energy technology into repeatable, scalable manufacturing output, shifting the investment profile from R&D-driven risk to hard assets defined by facilities, equipment, production capacity, and long-term deployment demand across mobility, energy, and critical infrastructure markets. Global energy revolution starts here. Solid-state energy has created a breakthrough. Magnetic power generation plus solid-state storage equals EVs and industries powered endlessly. Zero external charging. Core advantages of the solid-state energy industry. 1. Civil demand, transportation demand, defense industry demand. Solid-state energy industry focuses on magnetic power generation and solid-state energy storage technologies, aiming to create a new generation of long-life, self-circulating, zero-charging energy systems. Our core technology enables electric vehicles to operate from production to end of life without external charging, maintaining stable output in both extremely high and low temperatures. This technology fully solves the three major pain points in the EV market: range anxiety, performance degradation in extreme climates, and dependence on charging infrastructure. Environmental advantages superior to solar and lithium batteries. The production process of solid-state energy is pollution-free, and its usage generates absolutely no secondary pollution or harmful chemicals. This technology is the only viable large-scale alternative to solar panels and prevents the massive environmental waste created when solar panels reach the end of their 20-25-year lifespan. Solid-state energy materials pose no harm to the human body and avoid the reproductive health risks commonly associated with solar manufacturing. Strategic value in the defense industry. Our solid-state energy systems provide drones and unmanned surface vessels with up to 20 years of continuous operational power, requiring no maintenance or battery replacement. Its high-density power output supports military systems such as electromagnetic railguns, which require instantaneous high power, improving both efficiency and safety. Solid-state energy is a next-generation defense energy technology capable of delivering stable, long-lasting, and reliable power even in extreme environments. Solid-state innovation for a low-carbon world. Solid-state power pitch deck. Company introduction. Solid-state energy industries is a high-technology enterprise specializing in magnetic power generation and energy storage solutions. The company is dedicated to developing groundbreaking innovations that enable electric vehicles to operate independently throughout their entire life cycle, from production to decommissioning, without reliance on external charging. Core technologies. The company focuses on the development of proprietary and industry-leading technologies. Social and environmental benefits. These technologies contribute to reducing the potential environmental risks associated with conventional renewable energy, while mitigating possible adverse impacts on human health and broader social development. Executive Summary. American Sustainable Dynamics Energy Co. Ltd. is building the world's first fully automated production plant in Los Angeles, California, to manufacture the groundbreaking solid magneto power storage system, a combination of perpetual magnetic energy generation and graphene-based solid-state storage. This system enables complete off-grid, self-charging energy solutions for electric vehicles, AI servers, and more. Problem and opportunity, pain points. EVs require frequent charging and infrastructure investment. Solar wind are intermittent and location dependent. High maintenance cost of battery-based systems. Opportunity. Create the first scalable, no-plug energy system. Offer continuous clean power for vehicles, buildings, and remote areas. Our solution, solid magneto power storage system. Key components. Vertical magnetic generator with zero friction levitation. Graphene solid-state storage units. Bidirectional power converters. Advantages. No grid connection required. Zero emissions, no heat risk, no moving parts to maintain. Fully autonomous, long life cycle 20+ years. Core applications. Electric vehicles, no external charging. Smart homes and AI servers. Off-grid islands, disaster zones. Self-charging electric RVs. Military and mobile infrastructure. Business roadmap. Phase 1, LA facility producing energy cables Q1 2026. Phase 2, system assembly in Taiwan and Texas 2027. Phase 3, EV and RV production line in Texas 2029. Future, expand into Europe and Africa. Prototype performance. Completed proof of concept testing. Series connected magnetic generators exceeded 15,000 W. Stable AC output, 2,000, 12,500 V, 15, 50 A. Graphene storage performance validated. Global key market size forecasts mid to long term. High-end cable market. The high-end cable market is projected to reach $70 to $95 billion by 2030, driven primarily by new energy systems, electric vehicles, defense equipment, and high-power transmission demand. Electric vehicle EV market. The global electric vehicle market is expected to reach $1.5 trillion by 2030, with energy efficiency, endurance, and power stability as key competitive factors. Civil power supply and remote island energy market. The civil power supply and remote island energy market is projected to reach $20 trillion by 2035, covering basic power infrastructure, long-term energy supply for remote regions, and decentralized energy systems. Defense industry energy demand market. Energy demand in the defense industry is expected to reach a long-term market scale of up to $100 trillion, encompassing unmanned systems, military bases, advanced weaponry, and future battlefield energy supply. Off-grid and microgrid markets growing 11% CAGR. Strong ESG-driven investment climate. Regulatory tailwinds for clean, decentralized energy. Competitive edge. Patented technology. Modular, scalable design. Energy independence without external input. Cross-industry applications: auto, defense, telecom. Investment use of funds. Expand LA factory automation and equipment. Establish production lines in Taiwan and Texas. Phase 2, refund. Commercialize RV product line. Phase 3, refunding. Market development in APAC and Europe. YouTube presentations. Business plan, https, udo.bemwhitevap_eek. Smart automation, https, udo.beu7i2jk8m6ks. Risk and market analysis, https, udo.be-wordlrsd. Solid power energy industry plan. Phase 1, an automated production factory in Los Angeles, California, USA, will manufacture non-toxic, high-temperature resistant, high-end cables to supply the vast U.S. market and replace overseas suppliers. Phase 2, factories in Taiwan and Texas will efficiently assemble solid-state energy systems. The Taiwan factory will serve the Asia-Pacific market. The Texas factory will serve the Americas and Europe markets. Phase 3, the Texas automobile factory will scale up production of self-charging free RV camping vehicles. Future vision, expand business to Europe and Africa to establish global influence. Return on investment ROI analysis, please refer to Solid-State Energy Investment Outlook. Technological Innovation, ESG Drivers and Long-Term Return Potential. Low-Cost, Eco-Friendly Solid-State Energy Storage Investment ROI Evaluation. The following is an introduction to the automated production products of the solid-state electric energy industry after the factory has been completed. The main focus is on industries that meet market demand, aiming to reduce the burden on the power grid, permanently eliminate spontaneous combustion incidents in electric vehicles, stabilize the power supply system of autonomous electric vehicles, and reduce environmental air pollution. Solid Power Energy Industry is a company specializing in magnetic power generation and energy storage technology, committed to developing innovative products that enable electric vehicles to operate from the factory to the end of their life without external power charging. Our technology solves the main pain points of electric vehicle drivers, including no need to worry about running out of power while driving, driving safety in high-temperature environments, and difficulty starting electric vehicles in extremely low temperatures. Solid-State Power Industry Phase 1 Preliminary Industry. Automated Production Products and Equipment. Why do magnetic power generation equipment and the electrical energy storage industry require the manufacturing of a high-end cable industry? Because the high-end cable industry is the industry's bread, possessing strong profit margins, broad market demand, and the advantages of automated production. The market demand for high-end cables is extensive, with an exceptionally strong annual growth rate, providing stable industrial fiscal revenue. It is also the mother of the energy industry. High-end cables can extract the industrial production byproduct proprietary formula required to activate graphene, enhancing graphene's fundamental properties of high temperature resistance and superior cold resistance. Within high-end cable raw materials, a quenched extraction special liquid proprietary formula activates dormant graphene 8th-layer powder, altering the fundamental structural matrix of the graphene powder and transforming it into a high-temperature resistant, cold-resistant, high-capacity power energy storage reservoir. Phase 1 of the solid-state power industry focuses on a preliminary but highly scalable industrial foundation: automated production. Our initial application targets automated manufacturing equipment for high-value, high-end cable products. These are not commodity cables, but precision components that require extreme accuracy, consistency, and process stability. By integrating industrial automation with high-precision cable production systems, we significantly improve yield, reduce manual dependency, and enable repeatable, large-scale manufacturing. This is where solid-state power technologies meet real industrial demand. The value lies in automation, intelligent equipment, precise control systems, and production lines designed for efficiency and long-term scalability. This phase establishes the manufacturing backbone needed for future expansion across energy, infrastructure, and advanced electrical systems. Phase 1 is not just about production. It's about building a high-value industrial entry point with immediate market relevance and strong upgrade potential. Investment rationale. Why solid-state energy starts with high-end cables. Executive overview. Solid-state energy represents the future of advanced power systems. However, throughout energy history, scalable commercialization has never begun with the end technology itself but with foundational industries that enable reliable transmission, materials development, and immediate cash flow. High-end power cable manufacturing is the essential first step in building a viable solid-state energy ecosystem. High-end cables, the cash engine of the energy industry. High-end power cables are often described as the bread of the energy industry because they offer persistent, non-cyclical demand. Broad applications across industrial systems, buildings, AI servers, data centers, and power infrastructure. Highly standardized products suitable for automation. Stable margins with short cash conversion cycles. This makes cable manufacturing one of the few energy-related industries capable of generating immediate, scalable profits. The mother industry of energy materials. High-end cable manufacturing is not merely about power transmission, it serves as the foundation of advanced energy materials. During production, critical activation elements required for graphene activation can be extracted as high-value byproducts. These elements enhance graphene's thermal resistance both high and low temperatures. Improve long-term stability under extreme energy conditions. Form the backbone of next-generation solid-state energy storage materials. Without high-end cable manufacturing, scalable solid-state energy materials cannot be realized. Phase 1 strategy: mature markets with high margins. Phase 1 focuses on high-margin, automated, environmentally compliant cable products, including PVC cables VV, PE PVC cables, 600V control cables, 600V shielded control cables, XLPE PVC cable CV, high temperature resistant power cables. Target markets include commercial and industrial computing systems, household appliances and power cords, industrial automation and control systems, building power infrastructure, power and energy equipment distributors. These are established markets requiring no subsidies and no demand creation. Automation, the scale multiplier. The competitive advantage of high-end cable manufacturing lies in automation. Operational data shows, one fully automated production line equals the output of approximately 130 skilled workers. Continuous 24/7 operation. Consistent quality and minimal waste. Drastically reduced labor costs. Margin expansion alongside capacity growth. This positions cable manufacturing as a rare energy sector industry where scale enhances profitability. Investment conclusion: a rational path to energy transformation. The success of solid-state energy is not achieved in a single leap, but through a disciplined and verifiable industrial roadmap. Establish stable cash flow through high-end cable manufacturing, accumulate core energy material resources. Integrate solid-state energy storage and magnetic power technologies. Build a fully integrated, globally scalable energy solid storage, powder production process. Adopting core technology, advanced grinding and physical processing are used to produce low-cost operation and high-efficiency energy storage raw materials. Marlstone-derived rock times graphene. Solid-state energy storage material. The core material of the system originates from a specialized marlstone-based rock formation, classified within a stable gray crystalline heterogeneous structure. Through proprietary physical processing, the material demonstrates strong energy induction and storage characteristics, establishing a solid foundation for next-generation solid-state energy storage and power transmission applications. Graphene. Hardware electrical energy storage. Using proprietary physical refinement techniques, naturally occurring graphite within the source material is transformed into multi-layer graphene powder up to 8th layer grade, without chemical additives. This approach preserves high electrical conductivity, structural stability, and long-term material integrity, while significantly enhancing operational safety. The resulting solid-state energy storage structure contains no liquid electrolyte, offering a robust alternative to conventional lithium-ion and chemical battery systems. After formulation and structural integration, the graphene-based material is consolidated into a high-hardness solid-state energy storage body, designed for long-duration cyclic operation. Unlike traditional battery architectures, the system eliminates risks associated with thermal runaway and electrolyte leakage, substantially improving safety for industrial, infrastructure, and mission-critical power applications. Investment value highlights. Heavy checkmark: high safety. No explosion or combustion risk, suitable for critical infrastructure and high-value systems. Heavy checkmark: wide environmental tolerance. Stable operation across extreme temperature conditions. Heavy checkmark: scalable manufacturing. Primarily physical process-based production, enabling scalability and cost efficiency. Solid power industry. Magnetic power generation with graphene energy storage. No grid required, zero cost, zero pollution power supply system. Core technology of vertical magnetic power generation. Bearing-free, zero friction, shock-proof design. Specification sheet. Core technology explanation. Due to the involvement of magnetic energy, a peculiar phenomenon occurs: output-input. According to the law of conservation of energy, input plus magnetic energy equals output electric energy equals output electric energy. Because of rotational zero friction, the energy consumed by friction force is greatly reduced. With the involvement of magnetic energy, the result is output electric energy, input electric energy. Although some energy is consumed due to air friction, it is very minimal. If the entire device is placed in a vacuum, the effect is even better. Vertical magnetic power generator is different from the traditional generator, mainly utilizing inertial power generation. The electricity generated by the vertical magnetic power generator is first stored in the graphene power storage unit and then supplied to the load from the graphene power storage unit instead of being directly loaded by the magnetic generator, just like solar power is also first stored in batteries. The prerequisite for inertial power generation is high-speed rotation with zero friction. With rotation but no friction. The rotating object is completely magnetically levitated, having mass but no weight, with performance exactly the same as the Earth. Simply put, we are creating an Earth. In fact, all planets are the same as the Earth. The vertical magnetic power generator can operate efficiently for up to 20 years. When the performance of the strong magnet's magnetic energy declines, it can be recharged and enhanced to restore its original magnetic energy. It can be reused continuously without causing resource waste or pollution. It is truly a safe and environmentally friendly green energy, in contrast to solar panels, which can cause silicon pollution, and gasoline combustion, which causes air pollution. One application example: electric vehicle industry. Electric vehicles can operate from production to scrapping without the need for external power charging. A magnetic power generator equipped with a graphene energy storage module can serve as an energy supply for electric vehicles. the vehicle generates its own electricity, achieving complete self-sufficiency, enabling smooth travel even in remote mountainous or wilderness areas. The system can be custom designed according to the vehicle's energy needs, with tailored power specifications ranging from 1 kWh to 10 kWh. This eliminates the need for the current industry's costly and time-consuming construction of widespread charging stations piles, as well as the inconvenience of constantly searching for charging locations. Example: Electric Vehicle Power Consumption Unit, km kWh. X1, Tesla Model 3 Long Range AWD, Power Consumption, 15.6 kWh equals 100 km converted, 1 kWh equals 6.41 km. X2, Tesla Model S 100D, Power Consumption, 18.1 kWh equals 100 km converted, 1 kWh equals 5.52 km. 2. Solar or wind power industry. Solar power typically generates electricity for about 8 hours per day, with low conversion efficiency. If connected to a vertical perpetual motion magnetic power generator equipped with a graphene power storage module, it can achieve 24-hour continuous power generation. By utilizing the powerful vertical perpetual motion magnetic energy and its high-speed rotation with zero friction characteristics, power generation efficiency is greatly enhanced. Example: if the input electrical energy is 10 kWh, the output can reach 20 kWh. In addition, magnetic power generators have no rotational speed limitations, unlike traditional generators which operate under fixed maximum RPM constraints. Our zero-friction rotational device has no such speed restrictions. When the rotational speed increases, the generated voltage rises and the output current increases accordingly. Zero-friction rotation allows for high-speed operation, resulting in extremely high power generation efficiency, without concerns over the temperature limits of traditional generator bearings. 2 kilowatts for household or small vehicles, 10 kilowatts for refrigerated containers or large vehicles. The magnetic power generation system equipped with a graphene power storage module provides a power supply system that does not require grid connection, has no cost, and is pollution-free. It can be customized according to demand. Adjustable current, voltage, shape, length, width, height, etc. Magnetic-based power generation system. 2 kilowatts. Residential light-duty applications. 10 kilowatts. Mobile industrial logistics applications. Integrated power generation unit. Off-grid capable. Low operating cost. Zero on-site emissions. Graphene power storage module. Solid-state energy storage. Customized according to power demand. Our next core development is a magnetic energy power generation system, equipped with a solid-state electrical energy storage unit. This system integrates magnetic energy conversion with solid-state storage, enabling fast response, high stability, and long operational life. Unlike conventional energy storage solutions, solid-state architecture significantly reduces thermal risk and improves system reliability. By combining magnetic energy generation with solid-state storage, we achieve continuous power output, precise control, and high energy efficiency. This makes the system suitable for industrial automation, high-precision manufacturing equipment, and future energy infrastructure. More importantly, the modular design allows scalable deployment from standalone industrial systems to integrated power platforms. It is not just a power source, but a next-generation energy module designed for safety, durability, and intelligent control. This system represents a critical bridge between advanced manufacturing and the future solid-state power ecosystem. Our next core development is a magnetic energy power generation system, equipped with a solid-state electrical energy storage unit. This system integrates magnetic energy conversion with solid-state storage, enabling fast response, high stability, and long operational life. Unlike conventional energy storage solutions, solid-state architecture significantly reduces thermal risk and improves system reliability. By combining magnetic energy generation with solid-state storage, we achieve continuous power output, precise control, and high energy efficiency. This makes the system suitable for industrial automation, high-precision manufacturing equipment, and future energy infrastructure. More importantly, the modular design allows scalable deployment from standalone industrial systems to integrated power platforms. It is not just a power source, but a next-generation energy module designed for safety, durability, and intelligent control. This system represents a critical bridge between advanced manufacturing and the future solid-state power ecosystem. We have developed a magnetic power generation platform integrated with solid-state energy storage, designed as a flexible and scalable power solution. At the application level, this platform supports an electric vehicle solid-state energy storage module, engineered for compactness, safety, and high energy efficiency. The module measures 12 inches wide, 12 inches deep, and 28 inches high, making it suitable for space-constrained vehicle architectures and modular system integration. Despite its compact size, the module delivers stable power output, fast response, and long operational life, key advantages of solid-state energy technology. The enclosed design also enhances thermal stability and system safety, which are critical for electric mobility applications. This platform-based architecture allows the same core technology to be adapted across multiple use cases, from electric vehicles to industrial systems and stationary energy storage. It is not just a single product, but a scalable solid-state energy ecosystem designed for future deployment. Solid-state electric energy industry. Unlimited electric power supply systems, applications. Electric vehicle self-supply system. Electric vehicles from factory release to scrappage require no charging, achieving true self-supply of power. Vehicles supply power while in motion, permanently detached from grid services, never requiring charging throughout their lifetime. Unmanned aerial vehicle UAV unlimited electric power supply system. Power supply systems enabling unmanned aerial vehicles to operate continuously with unlimited electric power, eliminating dependence on conventional refueling or charging infrastructures. Unmanned submarine unlimited electric power supply system. Power supply systems enabling unmanned submarines to operate with unlimited electric power, supporting long-duration missions without reliance on external charging or fuel supply. National defense industry applications. Power supply systems for airplanes, large unmanned aerial vehicles, naval vessels, and other defense-related equipment requiring unlimited and continuous electric power capacity. Civil and commercial applications. Integration of unlimited electric power supply systems into community buildings, shopping malls, schools, hospitals, offshore islands, recreational forests, and other civilian infrastructures, ensuring independent and sustainable energy supply. Industrial and agricultural applications. Provision of stable unlimited electric power for artificial intelligence, industrial operations, agricultural facilities, community street lighting projects, and related industrial upgrading initiatives. Unlimited power applications EV self-supply system. One of the most transformative applications of our technology is the unlimited electric power supply system, starting with electric vehicles. We are developing an electric vehicle self-supply system, where the vehicle is capable of supplying its own electrical power during operation. From factory release to end of service life, the vehicle does not rely on external charging infrastructure. While the vehicle is in motion, power is continuously generated and managed internally, enabling long-term operation without dependence on grid services. This fundamentally changes how electric vehicles interact with energy, removing charging downtime, reducing infrastructure dependency, and increasing operational autonomy. In this model, vehicles are no longer passive energy consumers. They become active, self-sustaining power systems, permanently detached from traditional charging requirements. This approach opens new possibilities for mobility, logistics, and remote or infrastructure-limited environments, representing a major step toward true energy independence in transportation. Unmanned Aerial Vehicle Unlimited Electric Power System. Another high-impact application of our technology is the Unmanned Aerial Vehicle Unlimited Electric Power Supply System. This system enables unmanned aerial vehicles to operate continuously with self-supplied electric power, removing dependence on conventional refueling or external charging infrastructure. Power is generated and managed on board, allowing long-duration missions without forced landing for energy replenishment. By eliminating charging and refueling constraints, UAVs gain significantly extended operational time, higher mission reliability, and greater deployment flexibility, especially in remote, offshore, or infrastructure-limited environments. This capability fundamentally shifts how unmanned aerial systems are used. Instead of being limited by battery endurance, UAVs become persistent aerial platforms, suitable for surveillance, communications relay, environmental monitoring, and industrial inspection. The Unlimited Electric Power Supply System positions UAVs as autonomous, long-endurance assets, opening new operational and commercial possibilities across multiple sectors. Unmanned Systems Unlimited Electric Power Platform. Our Unlimited Electric Power Supply System is designed to support autonomous platforms operating in extreme and infrastructure-limited environments both in the air and underwater. For unmanned aerial vehicles, the system enables continuous operation with self-supplied electric power, eliminating dependence on conventional refueling or charging infrastructure. Power is generated and managed on board, allowing long-duration missions without forced landing for energy replenishment. At the same time, this technology extends naturally to unmanned submarine systems, where access to surface refueling or external power is highly constrained. With an unlimited electric energy supply architecture, underwater platforms can operate for extended periods while maintaining stable, quiet, and efficient power output. Across both domains, the core advantage is autonomy. These unmanned systems are no longer limited by battery endurance or logistical energy support. Instead, they become persistent operational platforms, capable of long-term deployment for surveillance, communication, scientific research, and industrial applications. This demonstrates that unlimited electric power is not a single use case, it is a scalable energy platform for next-generation unmanned systems across air, sea, and beyond. System architecture and power output applications. Our magnetic power generation system is designed to operate in a series-connected architecture, allowing multiple generators to work together as a single scalable power platform. In this configuration, magnetic power generators are connected in series, and the combined output is supplied to a graphene-based solid-state power storage unit, which stabilizes energy flow and delivers power directly to system loads. The system provides AC power output, with operating voltages ranging from 2000 to 12,500 volts, and current levels between 15 and 50 amperes. When multiple units are connected in series, total power generation exceeds 15,000 watts. For example, a configuration using 6 magnetic energy generators connected in series, integrated with solid-state storage loads, can support high-demand applications such as AI server power supply equipment. This scalable power platform is suitable for a wide range of deployments, including residential buildings, shopping centers, schools, hospitals, public facilities, islands, forest recreation areas, and electric vehicle chain charging stations. By combining modular magnetic generation with solid-state energy storage, the system delivers high-voltage, stable, and expandable electric power, independent of traditional grid constraints. Refined technology description: EV power independence. Our magnetic power generation system, integrated with a solid-state energy storage unit, enables electric vehicles to operate throughout their entire life cycle from factory delivery to end-of-life disposal without the need for external charging. This breakthrough technology directly addresses the most critical pain points faced by EV drivers, including eliminating range anxiety and concerns over battery depletion during operation, ensuring stable and safe performance in high-temperature environments, and enabling reliable vehicle startup even under extremely low-temperature conditions. In short, electric vehicles equipped with our system no longer require external power charging from the moment they leave the factory until they are ultimately retired. One-line key message: strong marketing version. Electric vehicles powered by our magnetic generation and solid-state storage system never require external charging factory to scrap. Solid-state energy storage, residential power supply series. Hello everyone, today, I'd like to introduce our solid-state energy storage power supply series, specifically developed for residential houses and residential buildings. This system provides a next-generation energy foundation for modern living, delivering safe, stable, and scalable electricity support for homes, apartments, and community housing infrastructure. Our solid-state storage modules are designed to ensure continuous power supply during grid outages, peak load energy buffering for high-demand households, and seamless integration with solar panels and distributed renewable energy systems. Whether installed in a single-family home or expanded across multi-building residential complexes, the platform is modular, reliable, and built for long-term safety. Most importantly, this solution focuses purely on power resilience and energy independence, helping residential environments operate smoothly under any condition. In short, our solid-state energy storage series is enabling smarter, cleaner, and more secure residential power supply for the future. Thank you. White heavy checkmark: power supply series applications. Residential backup power units, apartment and building energy storage systems, solar plus storage home integration, community microgrid support modules, peak demand management for smart homes, magnetic energy generation, integrated with a solid-state energy storage system, delivers stable and resilient power supply for commercial shopping malls. This solution supports continuous operation of critical building loads, enhances energy reliability, and enables sustainable, independent electricity infrastructure for large-scale retail environments. Expanded pitch version: investor client ready. Our magnetic energy generation technology, equipped with a solid-state energy storage system, provides uninterrupted and scalable power for commercial shopping malls. It ensures reliable electricity for lighting, HVAC systems, elevators, security networks, and high-demand retail operations, reducing dependence on external grid supply while improving energy resilience and efficiency. One-line tagline option: solid-state magnetic energy power solutions for next-generation commercial malls. Magnetic power generation system equipped with solid-state energy storage. Hello everyone, today, I am pleased to introduce our next-generation magnetic power generation system, integrated with a high-safety solid-state energy storage platform. This innovative solution is designed to deliver stable, independent, and resilient electricity supply to locations and industries where traditional grid access is limited, unreliable, or costly. By combining continuous magnetic energy generation with solid-state storage, the system provides uninterrupted power for a wide range of critical applications, including islands and remote communities, docks, ports, and maritime infrastructure, and commercial and industrial businesses requiring dependable energy support. Unlike conventional power systems, our platform offers key advantages such as long-duration electricity availability, enhanced operational safety under extreme environmental conditions, and modular scalability for both small and large deployments. In short, this technology establishes a new energy foundation supporting sustainable development, infrastructure resilience, and energy independence across diverse environments. Thank you, and we look forward to exploring collaboration opportunities. White heavy checkmark key application areas quick list. Island microgrids and off-grid power. Dock and port energy support systems. Commercial backup and peak demand supply. Remote business operations and industrial sites. Schematic of the solid energy industry. Hello everyone. Today I'd like to briefly introduce the schematic of the solid energy industry, which is built on three interconnected pillars. First, we have the magnetic energy power station. This is the primary generation source, designed to provide continuous and stable electricity, especially for areas where grid power is limited or costly. Second, the energy flows into our solid-state energy storage system. This platform ensures high safety, long-duration storage, and reliable power buffering under extreme environmental conditions. It acts as the core energy foundation between generation and end-use applications. Third, the stored power supports the AI server power supply system, delivering uninterrupted electricity to data centers and high-performance computing infrastructure, where stability and resilience are mission-critical. Together, these three components form a complete solid energy ecosystem: generation, storage, and intelligent power delivery. In short, we are building the next generation infrastructure for clean, scalable, and resilient energy powering industries, communities, and AI-driven futures. Magnetic generation plus solid-state storage plus AI power delivery equals the future of solid energy. Schematic of the solid energy industry. Hello everyone, today I'd like to briefly introduce the schematic of the solid energy industry, which is built on three interconnected pillars. First, we have the magnetic energy power station. This is the primary generation source, designed to provide continuous and stable electricity, especially for areas where grid power is limited or costly. Second, the energy flows into our solid-state energy storage system. This platform ensures high safety, long-duration storage, and reliable power buffering under extreme environmental conditions. It acts as the core energy foundation between generation and end-use applications. Third, the stored power supports the AI server power supply system, delivering uninterrupted electricity to data centers and high-performance computing infrastructure, where stability and resilience are mission-critical. Together, these three components form a complete solid energy ecosystem: generation, storage, and intelligent power delivery. In short, we are building the next generation infrastructure for clean, scalable, and resilient energy powering industries, communities, and AI-driven futures. Magnetic generation plus solid-state storage plus AI power delivery equals the future of solid energy. Magnetic power generation with solid-state energy storage. Our magnetic power generation system combined with solid-state energy storage is designed as a platform technology, targeting markets where reliability, autonomy, and energy security are mission critical. The first application focuses on agricultural energy solutions. Modern agriculture increasingly depends on electrification, from automated irrigation and greenhouse systems to remote sensing and autonomous equipment. Our solid-state energy solution provides continuous, self-supplied power, enabling farms to operate independently of unstable grids, fuel logistics, or charging infrastructure. This significantly reduces operating risk and long-term energy costs, especially in remote or climate-sensitive regions. The second high-value application targets defense-grade equipment and command and control systems. In these environments, energy availability is not a convenience, it is a strategic requirement. Our system delivers stable, long-duration electric power with solid-state storage, supporting communications, control centers, and mission-critical equipment without reliance on external fuel or grid access. From an investment perspective, this technology addresses large, resilient markets with strong demand for autonomous power systems. It creates recurring opportunities across civilian infrastructure and defense-related applications, while establishing a scalable foundation for future expansion into mobility, unmanned systems, and critical facilities. This is not a single product, it is a solid-state energy platform built for industries where power failure is not an option. Product portfolio: defense and UAV applications. Our product portfolio is built around magnetic power generation equipped with solid-state energy storage, designed for environments where reliability and autonomy are critical. At the core, we deliver defense-grade solid-state energy solutions. These systems provide stable, long-duration electric power for mission-critical equipment, command and control systems, and field operations. Unlike conventional power sources, our solid-state architecture reduces thermal risk, minimizes maintenance, and operates independently of fuel logistics or grid access, key requirements for defense and security applications. Building on this foundation, we offer power supply system solutions for unmanned aerial vehicles. By integrating magnetic power generation with solid-state storage, UAVs gain extended operational endurance and higher mission reliability, without reliance on conventional charging or refueling infrastructure. From an investment perspective, this positions the technology at the intersection of defense, unmanned systems, and autonomous power platforms, markets characterized by high barriers to entry, long procurement cycles, and strong demand for dependable energy solutions. These products are not standalone devices. Together, they form a scalable solid-state energy platform that can expand across defense, aerospace, and autonomous systems, creating long-term strategic value. Unmanned surface vessel and energy infrastructure impact. Our magnetic power generation product equipped with solid-state energy storage is designed as a high-reliability power platform for autonomous and infrastructure-critical applications. One key application is a power supply system for unmanned surface vessels. These vessels operate in environments where refueling, maintenance, and grid access are highly constrained. By integrating magnetic power generation with solid-state storage, the system enables long-duration, stable operation with minimal logistical support, significantly improving mission endurance, safety, and operational flexibility. Beyond unmanned vessels, this technology has broader implications for energy infrastructure. It is positioned to replace or reduce dependence on traditional wind power, hydropower, and thermal power systems in scenarios where stability, footprint, or environmental conditions limit their effectiveness. At the same time, it can support nuclear power systems by reducing auxiliary load requirements, improving overall system efficiency and resilience without increasing core operational complexity. From an investment perspective, this creates value across autonomous maritime systems, distributed power generation, and critical energy infrastructure. The technology is modular, scalable, and adaptable, not a single-use solution, but a solid-state power platform capable of reshaping how energy is supplied in demanding environments. Cost and public health impacts. Solid-state energy. Our magnetic power generation products equipped with solid-state energy storage are positioned as a practical replacement for conventional and variable power generation systems. First, solid-state energy systems provide a clear pathway to replacing fossil fuel-based power generation. By eliminating combustion, these systems significantly reduce air pollutant emissions around power plants. This directly lowers long-term exposure risks for nearby communities and supports improved public health outcomes, particularly in relation to respiratory and organ-related diseases that have been linked to prolonged pollution exposure. Second, from a cost and efficiency standpoint, this technology can replace or reduce reliance on wind power generation systems. Wind power depends heavily on weather conditions, requires large land use, and incurs additional grid balancing and maintenance costs. Solid-state magnetic power generation delivers stable, controllable output, enabling lower total power generation costs over time and more predictable energy planning. For investors, this represents a compelling opportunity at the intersection of energy transition, cost reduction, and ESG alignment. The technology is scalable, infrastructure efficient, and designed to support long-term deployment without the volatility associated with fuel supply or environmental dependency. This positions solid-state magnetic energy not as an incremental improvement, but as a next-generation power platform capable of reshaping how electricity is produced and delivered. Energy replacement, environmental risk, and long-term sustainability. Our magnetic energy generation products equipped with solid-state energy storage are positioned as a long-term alternative to conventional renewable and centralized power systems. In the case of solar power, large-scale photovoltaic deployment introduces growing challenges related to panel life cycle management and end-of-life waste. As solar installations age globally, recycling complexity, material contamination risks, and environmental exposure are becoming structural issues. Solid-state magnetic energy systems avoid panel-based degradation and offer a longer operational lifespan with reduced material disposal concerns. For hydroelectric power, while historically important, large-scale dams significantly alter land use and river ecosystems. These systems permanently change water flow, sediment distribution, and surrounding environments. As climate patterns evolve, increasing variability in rainfall, temperature, ocean currents, and atmospheric pressure introduces additional uncertainty into hydroelectric reliability. Multiple global studies indicate that extreme weather events are expected to increase in frequency and intensity over time. Power systems that depend heavily on environmental stability face rising operational and ecological risks. From an investment perspective, solid-state magnetic energy provides a more controllable, land-efficient, and environmentally contained power solution. It reduces dependency on large-scale environmental modification while supporting long-term energy resilience under changing climate conditions. This positions the technology as a future-facing energy platform, aligned with sustainability, environmental risk reduction, and long-duration infrastructure investment strategies. Solid-state energy storage, high-power energy supply applications. Our magnetic energy generation systems equipped with solid-state energy storage are designed to deliver high-stability, high-availability electrical power for advanced electromagnetic and directed energy platforms strictly from an energy and power supply perspective. One electromagnetic rail system, power supply support energy only. In electromagnetic rail system applications, solid-state energy storage plays a critical role as a buffer and stabilizer for high-demand electrical loads. The system stores energy, regulates discharge timing, and ensures consistent power availability for non-continuous, high-intensity electrical consumption. From an infrastructure standpoint, this architecture focuses on energy accumulation, power conditioning, and system protection, independent of any payload or operational performance. It demonstrates the platform's ability to support extreme transient power requirements in a controlled and repeatable manner. Power supply diagram, energy generation solid-state storage power conditioning load interface. 2 energy laser systems, power supply support energy only. Similarly, 4 energy laser platforms, solid-state energy storage functions as a reliable electrical backbone, enabling stable power delivery and rapid recharge cycles. The emphasis is on power continuity, electrical isolation, and system safety, not on output characteristics or application behavior. This highlights the scalability and flexibility of the solid-state energy platform in supporting next-generation electrical loads that require precision power management rather than traditional continuous generation. Power supply diagram, energy generation solid-state storage regulated power delivery load interface. Investor perspective. From an investment standpoint, these use cases validate the technology as a high-power energy infrastructure platform, applicable wherever electrical demand is intense, intermittent, and mission-critical. The value lies not in any single application, but in the core energy storage and power management capability, which can extend across defense infrastructure, research facilities, and advanced industrial systems. This positions solid-state magnetic energy as a strategic energy backbone technology, not an end-use system. Off-grid EV chain charging stations high-profit infrastructure model. Our electric vehicle chain charging station equipment is powered by a magnetic power generation system integrated with solid-state energy storage, designed to operate entirely off-grid. Because the system does not require connection to the power grid, it eliminates grid access costs, transmission fees, and fuel logistics. Power is generated and stored on-site, enabling self-sufficient operation with no ongoing fuel expense and no local pollution. This makes it especially suitable for building highway rest area charging stations in remote regions, including deserts, and infrastructure-limited corridors where traditional grid expansion is costly or impractical. The system delivers stable, large-scale power output, ensuring reliable charging availability regardless of location. From a business perspective, this model unlocks high-margin opportunities. Off-grid deployment reduces fixed operating costs while allowing flexible pricing and rapid site expansion. Instead of waiting for grid approval or infrastructure investment, stations can be deployed quickly wherever traffic demand exists. For investors, this represents more than charging equipment. It is a scalable energy and infrastructure platform. By combining autonomous power generation with EV charging demand growth, the system creates a profitable, repeatable, and location-independent business model with strong long-term upside. Phase 3 Self-charging electric RV and U.S. manufacturing expansion. Phase 3 marks our transition from energy systems to flagship mobility products. We plan to launch the world's first truly self-charging electric RV, ushering in a new era of energy applications for electric transportation. This RV is designed to generate its own electricity while driving, completely eliminating the need for external power connections. From the moment it leaves the factory to the end of its service life, the vehicle operates without reliance on charging stations or grid infrastructure. Energy is generated and managed on board, transforming the RV into a fully autonomous electric platform. To support this expansion, we plan to establish an RV production and assembly plant in Texas, USA. The facility will focus on assembling electric container truck heads and RV campers, integrating our magnetic power generation and solid-state energy storage systems directly into the vehicle architecture. This approach addresses a massive and growing market: long-distance travel, logistics, and recreational mobility, where charging access, downtime, and infrastructure limitations remain major barriers to adoption. From an investment perspective, Phase 3 represents product commercialization at scale, combining proprietary energy technology, U.S.-based manufacturing, and a high-value vehicle platform. It is not just an RV, it is a proof point for self-powered electric mobility, with clear expansion potential across multiple transportation segments. Future plans, timeline to be determined. Expand into Europe and Africa, focusing on the development of the EV and artificial intelligence assembly markets to create extensive and high-potential business opportunities. Proposed development area. Priority given to the Hamburg region in Germany, which offers a unique geographical advantage. It is strategically located to access the Northern European market to the north, the Southern European market to the south, and the large Eastern European market to the east. Additionally, it holds potential for managing the development of the African market. With exceptional environmental advantages and highly efficient infrastructure, Hamburg is an ideal base for business expansion and the global layout of assembly plants. Opportunities in Europe and Africa. The European market centers on advanced technology, policy support, and the demand for green energy transition, while the African market presents significant growth potential driven by rapid infrastructure development and rising demand for new energy. Conclusion: through accurate market trend forecasting and detailed financial analysis, we have identified our advantages in both technological innovation and market positioning. Moving forward, we will continue to optimize our strategies to ensure the project's robust growth potential and long-term value. Solid-state power automation manufacturing project. A next-generation infrastructure asset for energy independence. Global solid-state energy manufacturing hub. An institutional-grade opportunity for long-term capital. Solid-state energy automated plant. Converting capital into scalable, sustainable energy assets. Solid power energy industry is raising capital for Phase I of its manufacturing platform in Los Angeles, California. The proceeds will be allocated to the development of a highly automated solid-state energy manufacturing facility, designed as a scalable and replaceable long-term production platform. Total capital required for Phase I is $48 million. This project is positioned as a next-generation low-carbon energy infrastructure asset. Combining advanced manufacturing capabilities, technological barriers, and the potential for stable long-term cash flows, making it well-suited for strategic allocation by funds and family offices. Building a zero-carbon future with global long-term capital. Solid Power Energy Industry Los Angeles Automated Manufacturing Facility Project Preparatory Office. Project Representative Manager. American Sustainable Dynamics Energy Co. Limited. Email: usa.sustainable.dynamics.energy@gmail.com